So I'm going to do an example. Find the expansion of 2x plus y raised to the 5th power. Okay. Now 5 power is not too high. Probably if you're given a problem like this, it'd probably be like to the 4th power, 5th power, maybe the 6th power. It's not going to be too much bigger than that because it just turns into busy work after a while. I'll show you on the next video the type of problem where you would have higher powers. And it's not like a full expansion. Okay, so I just figure out real quickly what all the coefficients are this way. Those are the ones I want because it's the 5th power, right? So it's 1, 5, 10, 10, 5, 1. Those are my binomial coefficients. So I write that, that's what it's going to be. I put them in color so you could see where everything goes more easily. So first I get 2, so A is 2x. That's the thing, you have to realize that your A and your B can contain integers and not other than just variables, right? Or other numbers other than just variables. We'll use integers. So A here is 2x and B is y. So I get 2x to the 5th. The 2 is raised to the 5th as well as the x. The whole A, which is 2x, has to be raised to the 5th power, not just the x part, okay? Otherwise you'll get the thing wrong. Then the 5 comes, this 5 here comes from the binomial coefficient. So I've got those in yellow, notice, see? So that's where that 5 comes from. And then this is raised to the 4th power. It goes down 1 power. Meanwhile, the other one, which is y, starts going up in powers. Okay, the 10 comes from here. 10 went 1, 5, 10. I didn't write the 1 because you don't have to write 1. But 5, 10, right? This is going 5th power, 4th power, 3rd power. No factors of y, 1 factor of y, 2 factors of y, right? The next one will be another 10, like this. This will be squared, and this will be cubed. See? Not that bad, right? Once you get the pattern down. The 5 came from here. And then this is squared, so the next one is the single power. This is cubed, so the next one is the 4th power. Notice there's 1, 2, 3, 4, 5 factors. This counts as 1 in this case, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5, right? And the next one will have a binomial coefficient of 1, right? Which I won't write. And you just get y to the 5th. Because b is y. Now if b was like 3y, then I'd have to have 3y in parentheses to the 5th power. So I'd have to raise 3 to the 5th power as well. I just didn't want to make it that complicated on this one. Now notice, now you have to multiply these out. Why? Because you've got a 2 to the 5th here. Is a 32. So your coefficient of the x to the 5th term, is going to be 32, not 1. So you have to multiply that out. Here you have to take 2 to the 4th, which is 4 times 4, 16 times 5, right? It's 80. Here you have to take 8, 2 cubed times 10 is another 80. So make sure you multiply these out, right? I put them in different colors because they're combinations of things before, things of different colors before, right? Now, of course, now I'm just multiplying out the 2's, right? So it's going to be 32, 16, 8, 4, because it goes down a power every time. 4, 2, and then none. And then I'm going to combine those with the binomial coefficients. The binomial coefficients are just the ones in yellow. So they're 1, 5, 10, 10, 5, 1, with, of course, the ones I didn't write down. But the actual coefficient of the expansion can be, as you can see, can be very different from the binomial. The binomial coefficients only give you part of that usually. Unless it's just like a x plus y that you raise to a fifth power. Right? And it's really kind of a coincidence, well, kind of, that these two are the same. They're not always the same. It's just because I used a 2 here, it just works, and a 5, it just worked out that way. Okay? So that's the expansion, that's the answer. That's what they want, all the way down to there. Okay, so that's much easier than taking 2x plus y times itself 5 times. As complicated as this might have seemed, that would have been much harder. Okay, finally, let's do the next one in a second.